Hi everyone, it's been a long time since I've updated. In this video, we'll be working through a problem that is related to the concept of divisibility while further expanding the knowledge with questions on analyzing factors. After choosing thoroughly, I decided to talk about this question here. I noticed that this type of question were tested quite frequently in number theory. So let's get into it. Okay, so let's first read the question. For how many positive integer n is n over 30 minus n also a positive integer? Let's break this into half. So the first half of the sentence, for how many positive integer n, this is actually asking us to determine the number of positive integer n. Now, the second half of the question is giving us a condition such that n over 30 minus n will also be a positive integer, meaning it will also generate a positive integer as in n. So I'm not sure if this is still confusing, but it's definitely a revised version of this question. So hopefully, in further analysis, we'll be able to find the conditions and solve the problem. So after we have looked at the question, we should focus more on the expression n over 30 minus n. The first step that may come to mind would be simplifying it, because as you can see, in this expression, n is not only on the denominator, but it's also on the numerator. If we can simplify the form into the variable that appears only on the denominator or the numerator, then it would be more convenient for us to find out the values. One arrangement that we can try out is to think about removing n on the numerator, but at the same time, making sure that the denominator shouldn't be changed. Notice that n on the numerator is positive, as stated in the question, positive integer n. So if we can apply a negative n on the numerator, then the expression can be simplified. Knowing that we have to satisfy two conditions, one condition, removing n on the numerator, and the second condition is keeping the shape of 30 minus n. We can add 1 to n over 30 minus n, because n over 30 minus n plus 1, this is like a simple fraction addition, like you're adding fraction number to 1. So this is like n over 30 minus n plus 30 minus n over 30 minus n. Notice that n on the numerator has different signs, thus we can remove them, leaving 30 over 30 minus n as the simplified expression. Okay, so now the question becomes, how many positive integers can 30 over 30 minus n yield, or generate? Either way. Now look at the expression again. We see that n is a changing value. Why do I say that? Because 30 minus n is in the position of denominator, and 30 is in the position of a numerator. So then we can think about, is this somehow related to divisibility, and is this somehow related to factors? Because 30 minus n should be a much smaller number than 30, since that the question is asking us to find the positive integers of n. Well then, now the question is more simplified into 30 minus n can be how many factors of 30. Why? Because as long as 30 minus n is a factor of 30, then it's impossible to be a negative integer. Therefore, it will generate a positive integer. So therefore, it will generate a positive integer. Or in this case, to generate positive integers. In other words, if we can find out all the factors of 30, then the entire expression will generate a positive integer. Okay, we're doing a lot of question simplification today because now the question becomes how many factors does 30 have, right? So let me write this down. How many factors does 30 have? Well, think about it. If you would just simply list them out, then it would be okay for this question. But in other questions, if the question gives you like a really, really big number, then you would take a long, long time, and that would not be good if you're in a competition with a limited amount of time. And so if you ask me, then I would use the formula that I've shown in the last video, which, if you can recall, is finding the number of divisors of a composite number, which exactly suits for this question because 30 is a composite number. So I can highlight this for you. N is equal to P1 to the power of A1 times P2 to the power of A2 times all the way to Pk to the power of Ak. This is a prime factorization of that number. In this case, it's 30, and we take out the exponents and then put them in brackets and then plus 1, multiply them together, and that will give us the number of divisors. Okay, so let's try this. Just simply plugging them in. 2 to the power of 1 times 3 to the power of 1 times 5 to the power of 1. This is basically the prime factorization of 30, right? And then we take out the ones. So just 1 plus 1, 1 plus 1, 1 plus 1. Multiply them all together. This gives us 8 in total. We're not actually finished because bear in mind that the question states n is a positive integer here. Therefore, let me write this down. 30 over 30 minus n, it's only generating 8 integers. Thirty minus n cannot be equal to 30, which is one of the factors of 30. If it's equal to 30, then n is going to be 0, which is no longer a positive integer. Therefore, instead of 8 values of n, there will be 8 minus 1, 7 in total. Okay, so that's all for today's video. For a small extension, it would be nice to practice this question over here. I hope it's helpful, and thank you so much for watching. Until next time.